Okay, this is going to be a video on the trig graph characteristics. The notes are a little bit out of order, so you can sort of work backwards a little bit here. All right, what I'd like to start with is the concept of domain and range. Okay, all right, I want to start with the concept of domain and range for let's say sine and cosine. Okay, so the easiest way to do the domain and range for these things is sort of understand what the pattern is going to be. Okay, since the sine function does something and the cosine function does something like that, the domain will always be negative infinity to infinity. That's always. Okay. All right. The range, okay, is going to be the smallest value. All right, comma to the biggest value. All right, now, you do that by really making the chart and understanding what one period would be. Let's say it was even just something simple like y sine 6 sine of x, okay? All right, or 5 of x, sorry. So if it was 5, then what the values of sine are 0, 1, 0, negative 1, 0. So if I multiplied everything by 5, that would be 5, 0, 0, negative 5, 0. Only worry about one period. Well, so what would the smallest value be? It would be negative 5, the biggest would be 5. Okay, so that's the range. Okay, all right, so for the domain and range, you're just going to have to draw one period sometimes to help you. Okay, now let's talk about secant and cosecant. Okay, now remember these graphs are a little bit different. Okay, all right, this is the ones that have these U shapes with the undefineds. Okay, this is what we were looking at. All right, so the domain can be a little bit of a challenge. I want to talk about that second. For the range, okay, what you do for the range, let's say I had y equals 4, or let's say just regular cosine of x, okay? Cosecant of x, sorry. All right, the idea is, remember on the chart, okay, I got undefined, 1, undefined, negative 1, undefined, okay? Well, the idea is that it's going up and then down. So for the range, what you do is you do negative infinity to the smallest value, all right? And then union from the biggest value to infinity, okay? So in this case, this would be negative infinity to negative 1, union 1 to infinity, if you were trying to apply it, okay? All right, so that's sort of the concept there. The domain, and this is where you got to look at the asymptotes, okay? So x such that x can't be, okay? Your starting angle, okay? All right, because that will be an asymptote, okay? Plus the period of whatever the function is divided by 2 with an n here, where n is an element of integers, okay? And I'll explain that in a little bit. We'll have to do that through an example. But basically, the domain, because we have these asymptotes, we have to account for them. The first asymptote, okay, it will be the starting one, okay? So you'll do the concept there, and then you have to figure out whatever the period is divided by 2, because if you look at the period halfway through, you get your asymptote, okay? So that's sort of the concept with that, all right? For tan and cotan. Okay, and remember, these graphs are the ones with the asymptotes. I mean, I'll just do tangent real quick. Tangent looks like that, okay? So the idea is the range is the easy part, negative infinity to infinity. That will always be, and the reason why is it always goes, it's like the basically the cubic function, just goes vertical. The domain is similar to how we figure out secant and cosecant. X such that x can't be. It will be our starting angle, okay, whatever our starting angle is, plus the period times n, where n is an element of integers, okay? And the reason why is on the tangent graph, it's a little different. We go undefined, let's say negative 1, 0, 1, undefined, and that's the end of the period. So all you got to do is figure out how do you go from the beginning to the end, okay? So the idea of how these things are done will probably help you, okay? Let's do a couple of examples together. I'm going to do I'll do the cosine example first. let's do 3 cosine x minus pi over 2 plus 1, okay? So let's talk about the domain and range, okay? All right, let's talk about the domain and range. All right, so the domain, very easy. I automatically know that it will be negative infinity to infinity. Okay, that is easy. Okay, the range, I'm going to have an idea of the table of values. Okay, so for cosine, that would be 1, 0, negative 1, 0, 1. And that would be my table of values. Okay, that's the traditional one. Well, how would I change those? Times 3 and a plus 1. So that would be 3 plus 1 would be 4. That would be 0 plus 1, which would be 1. That would be negative 3 plus 1 would be negative 2. Same thing 1, same thing 4. Okay? So for the range, I know that it is going between negative 2 and 4. Okay? Because I know how the graph basically looks. Okay? So there's an example of that. Let's go to cosecant. Let's say I've got 6 cosecant of 3x plus pi, okay? All right, now, for the domain and range, I'm gonna have to go ahead and I'm gonna do a little bit more work with this, okay? The table of values still has some meaning, okay? So it would be undefined 1, undefined, negative 1, undefined, okay? So I only have to worry about one period. So what's gonna happen here? I'm gonna have times 6, so this would be 6 and negative 6, okay? So I can figure out the range actually a little quicker. It's going to be negative infinity to negative 6, union 6 to infinity, okay? All right, our smallest value, biggest value, okay? Sort of know how that lays out, all right? Now, the domain, I'm going to have to do a little extra work, okay? I have to find my starting angle. For cosecant, I do that by doing 3x plus pi equals 0. I would subtract pi. 3x equals negative pi, divide by 3, I get x equals negative pi over 3, okay? So x such that x can't be negative pi over 3, okay? All right, plus, okay? Now, what I'm going to have to do is figure out the period, okay? My period would be 2 pi divided by the number in front of x, which is 3, okay? So that's 2 pi over 3, okay? All right? All right, and divided by, all right, I gotta divide that by 2, okay? So that's gonna be 2 pi, I guess times a half, 2 pi over 3 times a half, which would be 2 pi over 6, which would just be pi over 3, okay? So plus pi over 3n, where n is an element of integers. So you can go ahead and go with that, okay? All right? So a little bit more work with that. So I had to get the period, and then I had to divide the period by 2, okay? So that's sort of how that works, okay? Let's do one with secant now, okay? Let's do one with secant. Let's say I've got y equals 2 secant of 4x minus pi, okay, minus 1. Okay, so domain and range. All right, now, gonna have to make a little table of values here. Undefined, 1, undefined, negative 1, undefined. Just do a one period. Okay, so what's gonna happen with the values? Times 2 minus 1. So that would be 2 minus 1 would be 1. This would be negative 2 minus 1 would be negative 3. Okay, so my range would be negative infinity to negative 3, union, okay, I would go 1 to infinity, okay? Now, this is where this gets a little bit tricky. Got to do a little bit more work with secant. Remember, our starting angle in secant, I take this and set it equal to negative pi over 2. So secant and tangent are one of those special ones, okay? So I would add pi, so that would be 2 over 2 to make a common denominator. It would be 1 pi over 2 with 4x, and then divide by 4. That's going to be pi over 8. That would be my first angle, okay? So x such that x can't be pi over 8 plus, okay? I got to figure out my period. My period would be 2 pi divided by the number in front of x, which is 4, which would be 2 pi over 4 or pi over 2, Now, since I'm looking for half of that, I would do 2 pi, all right, times a half, or pi over 2 times half. That would be pi over 4, okay? All right, that'd be pi over 4. So that's going to be pi over 4 n, where n is an element of integers, okay? So a little bit more work with that, all right? Let's go ahead and do a cotangent example, all right? Let's say I got y equals cotangent of 2x plus 3 pi over 2, okay, plus 6, okay? Now, what's convenient with cotangent is I automatically know that my range is negative infinity to infinity, okay? All right, my domain is the only one that takes work, so I don't even need the table of values really for the range, okay? All right, so how am I going to figure this out? Now this one I can set equal to 0, okay, so that would be 2x equals, I would have to subtract negative 3 pi over 2, okay, so I got negative 3 pi over 2, okay, divide by 2, so I would get my starting angle is negative 3 pi over 4, okay, so x is an element, all right, x such that x can't be negative 3 pi over 4, okay? Now, all I got to do is find the period here, okay? So my period would be pi divided by the number that's in front of x, which would happen to be 2, so that's going to be pi over 2, okay? All right? All right, so that's how simple that is, okay? Plus pi over 2n, okay? Once again, where n is an element of integers, okay? Once again, they're a little bit more complicated there. I didn't have to divide by 2 again because it's